session.
Afternoon.
How are you guys doing?
Okay.
Okay, so before we start, I just want to remind all of you about our test tomorrow. Yeah, you guys already announced earlier, okay, that tomorrow we have midterm test.
Yeah.
Yeah, so let me just share something here. Right, so this is part of the announcement from what I will copy this to our Google Classroom. Okay, this is a part of the announcement from our CC, Miss Jessie from WAN Campus. Right, so we are doing simultaneous tomorrow. Right. Okay, so I will share this in our Google Classroom. Right. But as you can see, you can screenshot lah for now. You can see that it's tomorrow evening, right? Okay, so starting from 6:15, you can connect to our Meet. I will share the Meet with you guys, right? Later. So 6 p.m. We connect to our Google Meet lah, yeah. And then some template will be provided between this time. Okay, as usual lah. This is online lah, right? Okay. So my worry is you guys have not, since you started, you guys have not experienced face-to-face exam, right? So the difference is that, one, you cannot rely on open book for our final exam. Second, the time constraint, right? Time constraint will be different from online. Okay, so for time constraint, for example, when we do online, we are given 3 hours and it's open book. Okay, and you have submission time half an hour. Whereas for full face to face, yeah, I assume they're going to do like before the pandemic, right? Same main question with sub questions. You have to finish within 2 hours. And when 2 hours is complete, you will have to stop writing and the answer script will be collected. So there will be a big difference lah in terms of time limit, okay, and the way you will be answering the questions. You cannot rely on open book, right? But for tomorrow, we're still going to be doing online, all right? So just to remind you guys lah. So question paper released between 6:10 to 6:15. And then from 6:15 to 7:15 is your time to answer. You will be given 2 questions, and each question will have sub questions, right? And then the marks will be 50%, but will be scaled to 100. Okay, so 25 marks for question 1, 25 marks for question 2. All right. So two main questions. Each main question will have sub questions. Okay, so after 7:15, you stop writing, and between 7:16 to 7:30 will be your submission time. All right, so you will be provided a Google answer template, yeah, to answer your answer lah, and then plagiarism checking will be switched on in the Google submission, right? So you have to turn in both Google document and save as PDF and submit also the PDF version. So you have to submit two version, one Google Doc version, one PDF version, right? And then as usual, you rename the template and the PDF and give your full name lah. There will be more instructions for tomorrow lah, how the rename will be, right? Right. So after 731 means if you late submission, it's quite strict as 0 mark, right? So coverage will be chapter 1 to chapter 4, right? So that means static default routing, OSPF, network security, concepts, and ACL. So I have to tell you, you must know how to set IP version 4 and IP version 6 static and default route. Okay, right? So for if you're revising today, for the routing, you need to know how to set IP version 4 and IP version 6 routing. Okay, and you need to know how to set up OSPF as well. Okay, set up OSPF. Uh, there will be a question based on network security, right? This one is just a theory question, network security. And then you need to know how to set up um, access list, numbered access list, and extended name access list. Is that okay?
Okay.
Okay, Noel, Kelvin, okay also? Farah, got it,
Okay.
okay? That will be the coverage, will be coverage for tomorrow midterm test. Okay. Any question on the midterm test tomorrow?
So fun. Almost same like that. Plus same like that.
Yes, almost the same. Well, actually, it's apart from the question, the whole process is the same as before lah. When we are doing computer networks. All right.
Okay.
Mm. All right. So, if you want to do revision on the net acad, you can. I open up the chapter exam for you to test out, to try out. Okay.
Okay.
All right. Okay. So, getting back to today's lecture, it will be on wide area network concept. So we're talking about wide area network concept. So let me share my screen. Okay, so I'll start to record. All right, so let's have a look at the topics covered in this chapter. All right, so we start with what is the purpose of wide area networks, right? And then followed by wide area networks operations. How does the wide area network works? Okay, how does it operates? And then we look at traditional wide area network connectivity. Traditional means how it used to be, and for some places how it's still uh, the infrastructure, how wide area networks are connected to each other. Right? Basically, wide area networks are uh, many local area networks connected together, yeah, remotely as well. Okay, so it covers a large geographical area, and the largest wide area network basically is the global wide area network, that is the internet, right? So how is WAN infrastructure organized? So we're going to look at the traditional wide area network connectivity, and then after that we look at modern wide area network connectivity. So what is the current and upcoming ways that wide area networks are connected together, right? And then after that, we look at like I said, the global wide area network, the largest wide area network, which is the internet. So we look at how internet are connected to each other, right? So look at the technologies, infrastructures, and look at it from the point of view of um, the what lah, the layer, Right. So let's start with purpose of wide area network. So this is basically what you have done last time when you asked to describe or define what is a wide area network. So the key word here is large geographical area. Means it covers um, a large area. That means more than cities. That means the states, maybe a region, entire country, right? Or even in beyond the boundaries of a country. So that means region in the world, and finally the global world, right? So uh, that means the wide area network telecommunication. The the way to describe is they are remotely large, yeah. Right. So here we see a comparison between local area networks and wide area networks. So again, the way we categorize between local area network and wide area network is through their coverage. Okay, so we've already said that wide area network is large geographically, whereas local area network are small. Okay, as small as your home, as small as a room, as small as a floor, as small as a building, and it might even extend to a couple of, a couple of buildings perhaps. Okay, maybe still in the same local area network. Any larger than that, then we are going into um, somewhere in between. I mean, in between here, maybe you have metropolitan area networks, right? But and larger than that, you are talking about wide area networks. So here is a comparison between LANs and WANs. Okay. So here the contrast is small geographical area, whereas the wide area network is large geographical area. Okay, so LANs we know that is basically connected together. The modern LAN, yeah, connected together by a switch, right? So switch connects all the local computers as your end devices, yeah, peripherals and maybe VoIP phones, any device that's connected to your switch to form the small local area network. Now, the moment you start to connect the LAN to another LAN, then you start to use the router as your intermediate device, right? So the moment you connect two LANs together, right, and if the coverage is a large geographical site, then it will be considered as a wide area network, right? So most LAN does not need to reside in order to be connected together, does not need to be beside each other geographically, does not need to be sited near to each other. They can be remote. Okay, two LANs might be separated by thousands of kilometers and still connected together, right? So when when we have a large area network, okay, where we connect LANs together, yeah, that is when we are talking about wide area network. Okay, so typical things that we can do with WANs is that your users might be accessing remotely, right? And we're start thinking about LANs as network that is interconnected to form the wide area network. And we start thinking about sites, means sites geographically separated quite a distance, right? And then we connect them together to form a wide area network. And usually a LAN definitely will be owned by a single organization, or from the consumer point of view, the typical consumer, the public, that means a typical home land will be owned and basically maintained or organized by the home user itself, right? But wide area network, usually because of the infrastructure, are usually owned and managed by an internet service provider, right? Or telephone company, or cable company, or satellite company, right? They all provide this service. The thing is, in a land, you can afford to buy your own cables to connect all your devices and devices to a switch. That means you can purchase and operate, manage, and maintain your own networking devices and also your end devices. But when you are starting to go into a larger geographical area, then the infrastructure becomes too cost prohibitive. That means it becomes too expensive for any one organization to basically purchase and maintain. So normally, when a business scales up, okay, and scales up to have many branches, to be sited at uh, in different sites, right? Then the infrastructure that is needed to connect lands that is also probably sited at different sites together will be too expensive, and probably you can't get the license. You can't get the license unless you got a like a service provider license, to actually, even the ISPs usually they don't operate on the infrastructure side. That means they do not provide. That means they piggyback on another telecommunication company. For example, in Malaysia, Telecom is the one that is providing a lot of this infrastructure, okay, physical infrastructure, because they are a telecommunication company. Now, when you talk about Unify and TMNet, all these are subsidiaries that aims to compete with the other service providers. So service providers usually provide the service to you, for example, to connect your network via wide area network, right? But the infrastructure itself, right, usually owned by a telecommunication company, a large and quite substantial telecommunication company, like in our country, like Telecom, right? Or for wireless services like Celcom, okay, they are quite big, so they're able to roll out their own infrastructure, the towers needed, okay, there's a lot of, like, well, for example, if you're providing a fiber optic, then now we'll start to look about the deployment of 5G. So uh, some of the companies, the large companies, are entrusted with a provision of the 5G infrastructure. And then there are other ASP that will then uh, buy a package from them, and then they will resell it to consumer, right? Okay, so looking at the costs, the difference, why I say cannot afford, because although you need to pay for your wiring, your intermediate device like switch, maybe a router, and also access point, and also your individual, it's still considered that cost is still considered cheap, yeah, right? And there is to operate the LAN, basically once you set up everything, the LAN is free apart from the connectivity if you want to go outside of your LAN, right? But WAN services, the broadband that connects your LAN on different sites together, these services are not free, right? In order for you to use the infrastructure, telecommunication infrastructure, to carry your communication, your network communication, then that is when you have to purchase a service package from the service provider, right? Okay, so LANs, because the distance of their cabling and even wireless is short. Therefore, you could rely on a stable and very high bandwidth speeds, right? Compared to that, you cannot maintain that kind of speed unless you're doing you know very high bandwidth optical fiber kind of medium, right? Usually the speed achieved at the wide area network is slower than what you can achieve cheaply on lands, right? So that's the difference lah. Okay, you can see the contrast between the lands and the WANs. Okay, right. So there are two types of wide area networks, private and public. A private wide area network is a connection that is dedicated to a single customer. Then again, I said customer normally have to purchase, okay, the service that connects their remote sites together, remote networks together, remote LANs together, right? So there are services where you can purchase for a high fee. Okay, if you look at what is provided by Telecom or TMNet, the Swiss private wide area for businesses means nobody is sharing the connectivity. Yeah? That means depending on what kind of technology they provide, that will give you what kind of speed and stability you have. But normally, once you purchase that from the provider, service provider, your your wide area network will be private to you. Means no matter what, that service is not shared with any other customers, right? So you have sole use on it. So means the bandwidth will be used by you and you alone, right? So what you get is you can have guaranteed service level. Means because you're not sharing the bandwidth with anybody else. Okay, this is like, for example, using lease line to provide connectivity between your remote sites, right? Nobody is sharing that bandwidth with you. Whatever bandwidth you are purchased based on the service will be that bandwidth is solely for you. That means you have a guaranteed service level, consistent bandwidth, right? Because you're not sharing with anyone, you control your own bandwidth. You use more, then of course bandwidth go down. You use less, then bandwidth go up. For example, another thing that a lot of companies really do why they want to go for private is security. Since you're not sharing the infrastructure, the communication line with anybody else, you can be guaranteed the security. No one can go and eavesdrop because they have no access. Okay, they have no access to your communication line. So that means you can be assured of security, right? No man in the middle attack, for example. A public wide area network connection is usually enabled by the use of the normal internet communication infrastructure, which means you need your traffic will go through shared bandwidth, satu, and secondly, it's not consistent, right? Because depending on the usage of the bandwidth whereby you connect to the internet, whether there's a lot of user, there's peak hours, there's a low peak, there's high peak, right? So you find that certain times in the day, your the bandwidth will go down, and sometimes, especially during um, midnight or something like that, then you'll be faster. Security wise, it's very insecure, right? Very insecure because you're sharing the bandwidth. Other people in the public can easily intercept, right? Intercept your communication. Therefore, a lot of times, if you do, because of cost, you do have to use the public wide area network connection. You have to do some encryption, right? So your data in transit during the communication will not be easily intercepted by um, public because it's encrypted. Even they intercept, they cannot open up, they cannot view inside. So usually, this kind of security for public WAN connection is by using virtual private network or VPN, right? Right. So in terms of wide area network topologies, there are few topological design. So each of them has their own pros and cons, lah, right? So we just list out here first, and then we go through each one by one later. So we have point-to-point topology, hub and spoke topology, dual home topology, fully mesh, and partially mesh topology, right? So if your organization has a very large network, usually you don't just pick one topology, right? Usually you combine, okay? You be using a few of this topology at the same time, depending on the needs of your organization, right? So when I give you example later, when go through the slides, you'll see what I mean, yeah? So let's look at the point-to-point topology first. Right? So now remember, if this not necessarily for long distance, although we say it's point-to-point topology, yeah, logically it may be point-to-point, but physically it may not be point-to-point. especially when you see a cloud here. This cloud represent a network here, okay, that's hidden inside the cloud. So logically, you will see as if your communication from your site A to site B may be just a direct link, right? For all purposes, it might seem like it's a point to point, right? But it's actually only logically point to point, okay? Because if you look at the implementation here, it might be a not a point to point physical connectivity, right? So it says point to point topology employs a point to point circuit between two endpoints, right? And then it involve a layer 2 transport service through service provider network. The point to point connection is transparent to the customer network. Okay, so you are not even aware that it's a point to point, whether it's actually physical. The thing is, it's very, very expensive, but it's traditionally this is the way that it was created, whereby physically, yes, you have a point to point physical connection between site A and B, but that kind of service is because you're basically renting or leasing a part of the infrastructure for yourself, right? Especially if you're doing lease line, then it's going to be very expensive. But it's possible, okay? It's possible if the provider is has this kind of service, they are able to basically lease out a physical point-to-point connectivity, between site A and B. But modern networks usually now replace a physical point-to-point with logical point-to-point. All right. So just to let you know lah. Then before we move to the next one, usually this point-to-point topology is suitable for connecting two sites. Let's say you have a site A, which is your main HQ, and then site B is your branch, and then you only have two sites, yeah, and then you want to connect them directly, then point-to-point topology is suitable for that. But sometimes if you are you scale up your organization, that means you have more than one site, more than one branch, right? Then you might want to do something like a hub and spoke topology. This is the hub and this is the spoke, right? A spoke, like a spoke on the bicycle wheel, right? From the middle of the bicycle wheel, you can see the spoke irradiate from the center to the edge, right? So it's a very similar, all right? So in this way, even though possibly spoke A and spoke B, they are close to each other, well, not that close, but you know, you cannot have a direct link between spoke A and B, which means in this kind of topology, all the spokes will congregate together onto the hub, and the hub acts as a virtual circuit, right? Virtual circuit that will then relay back, right? Relay back the communication to whichever spoke, right? So for spoke A, communication go to hub. Hub A wants to send a communication with C, want to communicate with spoke C. So spoke A, okay, doesn't have a direct link to spoke C. Spoke A will send the communication to hub, and then from hub we'll redirect it to spoke C, right? So this is if you want to see an analogy of this kind of infrastructure, you can look at the typical train, train kind of network. Train network, you have a central location where all the trains will arrive there, and if as a passenger you want to go from maybe city A to city B, still you can't go direct. You have to go all the way to the hub, right, and change train there, and then you can go to the next city serviced by the hub, right? And we can also see this pattern in airplane flight. Airplane flight. It means if I want to go to Hong Kong, maybe not Hong Kong, I will go to Japan. I cannot get a flight from KK to Japan directly. Our central hub is KLIA, so from KK I have to go to KLIA there, and then from KKI to KLIA, and KLIA, then go to Japan, right? So it works. The idea is basically like that. Now, this kind of topology has a single point of failure. Simply means this hub is the single point of failure. If this hub fails, then communication between any of the spokes will be interrupted. Okay. Right. So the next one is dual home topology. It's basically an improvement of this hub because of this single point of failure. So how do you avoid single point of failure? We already know that in networking, we always try to do redundancy. We always try to have a backup. So this is basically a topology that provides backup for your hubs. So here we have two hubs, right? So when we have two hubs, one hub can be as a backup hub. Then so that means we eliminate the problem with a single point of failure. So if one hub go down, the other one is still there to provide connectivity, right? So we call this a dual home topology. It's more expensive, of course, because everything is duplicated. Although it's here is highly simplified, because we only see two hubs, and we just look at that. Whenever you see the cloud here, we try to it's a way for us in networking to hide complexities. Yeah, we want to hide all the complexities here, don't need to show, right? So when you see this kind of cloud appear, right? So actually it doubles up everything lah. So that to provide, to avoid single point of failure, you provide redundancy, right? So that means additional hardware is needed. Okay, additional hardware means additional routers, additional switches, and stuff like that. All right. Okay. So, but at least for this, especially in mission critical system, where you need the network to be up all the time, this kind of topology provide us that security. Security of always on. Okay, network always on. Right. So we go to the last two topology. Right. The first one, a fully meshed topology, uses multiple virtual circuit to connect all the sites. Right. So connect all the sites means every site is connected to every other site. Now you can see even with 4, the connectivity is 1, 2, 3, 4, 5, 6, right? 6 already. 1, 2, 3, 4, 5, 6. 4, 6. If you add one more, so you can see the growth in the connectivity. This connectivity needs to be implemented, right? And the way it scales up is not linear, meaning to say if I add in one more side, then it's just another set. No, it's not. Because it's full connectivity, a full mesh is full connectivity between sides. If I add another side, the way if I plot the graph, that means the scaling up of all the facility, the infrastructure that I need to provide for the additional site will grow logarithmically. Means very quickly, right? Very quickly, you will find that the cost to provide the connectivity, connectivity will be prohibitively expensive, right? Can you imagine? Just add one more, then suddenly you add 1, 2, 3, 4, 4 on top of the 6. Yeah, I think it's 4. Becomes 10 already. I'm not sure. You guys can try and then try and add another one. See the connectivity needs to be provided. But this is the most fault tolerant topology because every other site is connected to every other site, right? So it is very resilient against failure in the network, right? If one path is down, there are multiple other paths that can be taken by your communication. So it's the most fault tolerant topology of all. But again, like I say, the real life implementation costs a lot of money because you need to the infrastructure that you need to provide to enable all connectivity, yeah, is very expensive. But people do acknowledge about the fault tolerant nature of this topology. So usually they will settle for partially mesh topology. Partial mesh means you still provide multiple paths, but no longer fully connected. Right? Some connection, depending on the whether that site is critical or not, will have less connection on. For example, if these three are more important to have full connectivity rather than this site. Okay, in this site, if it goes down, then not really that critical. Then they will, due to budget, they will deem that all right. So this is not so serious. If this one go down, the path to this site. So they will allow not to spend additional connectivity. Right? So since now we don't have full connectivity, it means we only have partial connectivity, means partial mesh topology. So this is like in the middle ground, right? Between the budget to implement uh, the full mesh and the need to have fault tolerant topology. So here we save some costs. We identify sites that don't really need to be fault tolerant, right? So we can save some money there. But for sites that needs fault tolerant, then we provide the connectivity, right? So hence it's called partially mesh topology. All right. All right. So carrier connection, right? So carrier connection simply means who are the service provider. How do you connect? How do you, as an organization, connect to the internet? So this is again another aspect of wide area network design, right? So usually, you as an organization, you have no access to the top level internet bandwidth provision for your particular country, right? Usually, it's a range of very high level, right? And usually the government controls the provision of the connectivity to the internet, right? So as an organization, the best you can hope for is you can basically, if usually when the government have this bandwidth, the government will then monetize it, yeah, monetize it by having companies operate the site where to basically provide the service, right? So an organization, when they want to connect to the internet, they will then deal with that with those service provider. So usually they sign a service level agreement with a service provider. So service level agreement is depend on what the service provider have in their package. Yeah, what are the services, what kind of guarantee, what kind of reliability, availability, speed, bandwidth. Okay, so all the necessary requirement needed by the organization, right? They will have to negotiate with the service provider. Okay, most times service provider already have a template. That means they already have services that they basically sell to businesses, right? So normally a business, their needs are basically the similar when it comes to connectivity to internet. It's just whether what level of service they want, and they of course it will be priced accordingly, right? But sometimes when the organization is large enough, so they have the cloud or they have the budget to basically create a separate contract with the service provider, right? So it depends, yeah. Right. So the service provider may or may not be actual carrier. So for example, whenever we see the service provider like DG, we expect uh, that maybe DG is the one that provides us the infrastructure, but it's not. So that means they are not the carrier. So there's a two layer. Okay, the actual carrier that basically give the access to the backbone of the internet, right? Already divided lah, right? They divide the kind of connectivity from the backbone of the internet to the service provider, and the service provider will then chop it off even more to provide to businesses or to normal consumer. So the service provider may not be the actual carrier, but they may also be, for example, subsidiaries of telecom. So telecom, for example, is can you can imagine as a carrier. They are the carrier, they're the telecommunication company, right? But as a telecommunication company, they don't sell retail. But let's say they also want to join into the market, right? So they create a subsidiary like Unify and TMNet, and the Unify and TMNet will then focus on servicing the consumer, whereas telecom will focus on being the actual carrier, maintaining all the infrastructure, laying out cables, laying out whatever is needed to expand or to maintain the current communication infrastructure, right? So you can see a carrier owns and maintains the physical connection equipment between provider and customer, right? So basically, if you want Unify, then you can see then come in and lay out the fiber optic cable, the last mile, right? But then DigiCable, how? DigiCable also provide bring in their own cable if you want to get for Digi broadband, fiber optic. But then the main cabling, the main infrastructure for the cable uh, that connect to the internet backbone. Okay, so that means the service provider do not do that anymore. That means the actual telecommunication company like Telecom is doing that, right? So, as an organization, if you are in a country where you have a single carrier or dual carrier, you get to choose lah. Most of the time, you get go for single carrier, but sometimes you go for dual carrier, right? So, but there are certain infrastructure nowadays. You can some of the because of example, telecom can create subsidiary to participate, okay, in the to provide services to consumer. But at the same time, the service provider can also, if they get funding, they can also jump a level higher to actually lay out their own infrastructure as well, right? They can, right? For example, Cellcom been also creating their own infrastructure in the mobile space, in the provision of 3G, 4G. I'm not sure about 5G. 5G, I think right now they're dividing among themselves who is going to be doing the infrastructure and basically providing the services down to consumers or organizations. Right. So why do organization go for dual carrier when they can go for single carrier? Well, again, it's about the redundancy, right? Last time I remember before the pandemic, we were still able to bring our students, okay, for example, you guys, to outside companies, to visit, right? To learning visit. So one of the company that we went to was the Sabah Credit Corporation, which is in Dongmen, right? And when we reached there, we actually are shown around the infrastructure of their computing, computing services. Now, one thing that we noticed is that they have different connectivity for their network, for their internet. In fact, they not only go for two connectivity but three. That means one main connectivity, internet connectivity, and two backup connectivity. So the main one basically is if I'm not mistaken, is I'm not sure. I don't think it's fiber optic. It's probably a lease line. And the second one is an older list line, ISDN type list line, or was it ISDN line and then ADSL line? But I remember the third one. The third one they actually have is the satellite connectivity, satellite line, right? So the best thing about their multiple different connectivity is that they are all different using different types of communication, right? So if any one failure, the other backup communication line to basically connect to their branches or whatever, right? Is using a different type of communication framework. So, for example, then the lease line basically using maybe ISDN line, right? And another line is using satellite, right? So sometimes they will go for different carrier, right, or different service provider. In in terms of carrier, because our country is a single carrier country, so that means there's only one, which is telecom, right? So all of the services also go through telecom. But in some other Western countries, they actually open up the telecommunication sector, right? So you have a few very large telecommunication companies that you can choose which one you want, right? In any case, in Malaysia, we do have something like this, but more like a service provider, right? So the attractiveness is basically having a backup, a redundant service. If one SP goes down for whatever reason, the network is down, right? If you go for both the same ISP, if what happens to cause the network problem here is basically internal to the ISP. So the second line here also will be affected because it's the same ISP. So the reasoning is if you go for two different ISP, the first ISP, if it fails due to whatever internal network problem they have, the second ISP, since it's a different organization, is a different provider, then less likely that the same problem affecting the first ISP is going to affect the second ISP. The only thing I can think of that can all ISP will be affected will be underwater fiber optic cable got damaged. Then yes, it will affect. Doesn't matter which is the carrier or whatever, that will damage everybody. But if it's apart from that, it could be something about their own network. So if you go for different ISPs, then that will give you opportunity to still be able to use that particular line. All right. So I give you one example very recently. I went to uh, basically what pharmacy. This pharmacy, their their credit card or their card processing is via public bank. So they actually it is that means the same service, but it's tied to the public bank. And but basically, when it's come time to pay, the service is down. So no matter the owner of the pharmacy tried to connect to a different network, still having the same problem because it's internal to that merchant, right? Internal to the merchant system that they're using, which I saw was public bank, right? And so when she checked with other branches, or other pharmacy, they all those who have the same merchant, they're all affected. They're all means their whole payment system down, right? So this is what we say, right? We don't want now. This is actually very bad, right? This in terms of business is very bad. So if they are having a secondary backup merchant or whatever, right? Then they can simply switch over, right? And utilize that. Okay, so that's just an example. Although here we talk about network connectivity, having having different ISPs provision means it's safer, right? Just in case there's a problem. Right.
So
Yes.
does having two SLA increase the cost?
Yes, definitely. This will
Okay.
increase the cost, but you always have to balance, Noel. Is is what is critical for your business. So it depends on what is your business doing. If your business is doing, for example, if doing e-commerce, right? If you're doing e-commerce, having a single line, right, that provide the internet connectivity to your e-commerce site, right, is bad because once it's down, your business stops. Okay, of course, the modern ones they use cloud, right? Cloud has the distribution. So just imagine that you have your own data center, huh? So if your ISP go down, then no one can access your e-commerce site already. Then that's a problem. That's a problem because uh, every minute you lose connectivity is every minute potential customer loss. So you have to balance between your operation. Is it really crucial to have that online capability? I believe, for example, like banks, right, finance companies, it is very crucial because they operate online banking, they operate ATM system. So the ATM system, right, is crucial for people to be able to withdraw money. So if you have two separate, then you might say, oh, I double my expenses. But then think about uh, if you are down for, let's say, 1 hour, half hour, what is the cost to your business, right? So it's a balancing act between uh, having the safety, the critical business process up and running all the time, or paying for the extra redundant ISP. Okay, so I can tell you most of those companies, organization that really rely on network. I think most companies nowadays also rely on, very much so. If they rely on the network connectivity for their, you know, bread and butter, their business to operate, I think having a separate ISP is it becomes like a necessity, right? A necessity already. Right. So yeah. Any other question? Does that answer your question, Noel?
Yeah.
All right. So we move on to um, a different topic, evolving networks. So the thing is, here we talk about the growth of your company, the growth of your organization. When your organization grow, that means your computing needs, your networking needs, your IT needs all also scale up. It will grow as well. It goes hand in hand because nowadays a lot of competitive companies they depend on IT, right? So when the company grows, scale up become more profitable, they expand, they scale up. That means the IT needs also will grow, right? So IT includes the network right? Because no computer is actually nowadays disconnected. They are all online. They are all connected, right? Because of the advantages, right? So that means if you have a potential, when you look at your planning, your company, you say, I want to scale. I know my target is my company becomes bigger, scale up. Then when you look at your IT, you look at the IT, you look at the network, right? Then your network also must be able to scale up together. You don't want your IT needs, that means here we focus on network. Your networking needs is the one that is holding back the growth of your company. So that means any plans you have for your company to grow, to scale up, must also include the plan for your network to grow, right? So that means if you of course, the boss, they deal with business process, they deal with business decision. So a lot of this scaling of network capability is down to the people they hire lah, like network designers and network administrators. That means uh, you've seen already how the we can extend, the difficulties, the advantages, the pros and cons of when you grow your network, right? When you extend your LAN, right? We've already looked through the the issues, right? So you 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 as a network designer administrator, you need to be ready lah. Be ready. You need to design your network to be scalable. That means including the network technologies, protocols, service providers, and all sort of things lah. You may remember we want to provide larger network, and then suddenly we notice problem, right? The what do you call that? The broadcast domain enlarge. Then you think, oh, okay, I use virtual LAN because then I can segment my network, my physical network. Then what about inter-VLAN routing? Oh, I cannot, if I scale up beyond certain number of virtual LANs, a router and a stick doesn't work anymore, so I have to consider buying a multi-layer switch. So these are the consideration as you grow your network. Your network grows because your company grows, right? So for example, at first you only have like 10 salespeople. Due to very laku or whatever, your product, whatever, now you grow very fast. Within 2 years, from 10 salespeople, you got 50, 60. Each of them needs a terminal or needs a workstation. So now you have to provide a network with 60, starting with 10, you now have to provide for 60. But then that's only the sales. What about marketing, right? Then the human resource also to look after, also grow, uh, you need more computers. So as you can see, as you grow, right, the network needs to be able to grow as well, right? So here it says to illustrate differences between network size, we're going to use a company, this one is a fake company lah, just for our example, called Span Engineering. As it grows from starting as a small company, becoming local business into becoming global enterprise. You'll be surprised. Some companies see a meteoric rise. If you don't believe, look at Grab. How fast did Grab grow from just being a small player behind Uber? Uber was the one to beat, right? And Grab was just starting out. If you check how many years did it took them to become the leader in Southeast Asia, right? It it can surprise you. Sometimes company when it really grow scale, it really can become very big, right? Very fast. So let's look at Span. Okay, so it's a small company, right? So it's only a few employees, like a startup lah, right? We can think of it like a startup, right? So they only have a Soho, small office, home office, right? Few employees only. So that means they need only a single LAN, okay, connecting wirelessly via wireless router, right? So they just, because there are only a few, the bandwidth not much requirement, so they go for ADSL. ADSL is just an imbalance speed for upload and download, whereas DSL is balanced, right? So it depends on the service provided by the service provider, right? So basically, IT support, if they need IT support, they can just go to the DSL provider and ask them to come lah to check their network. Not really much to do, right? They have computer and all connect wirelessly. Very simple setup. Okay, and broadband access is basically probably even not even a business line. Okay, in this country we separate, right? Business line, and home user line, two different things, and two very big different price, right? So they grow very quickly. They become something like a campus network, right? So campus network simply means, you know how big a campus can be. So ours is actually quite small, although it's sitting on 5 acre land. Well, you can say that that can be as an example already lah, our Alam Masra campus, because we have network all over the place, and there are different lands, right? So you can say the student labs, and then you have the admin labs, you have the lecturers lab, and so on, right? So it becomes more than one LAN, becomes more like multiple LANs, okay? And they are all connected together, right? So it could be several. If we are sited in a building, it could be several floors. Each floor basically a LAN, and then they're all connected, as you know, by routers, right? And then we have the main router connecting to the internet. So now, because there are more people, last time it's enough to have firewall in each individual computer. Now we have to centralize the security. That means we have to have a firewall, right? A firewall to protect our networks, our LANs, right? So now, because we have more LANs, more end devices, then we now hire a dedicated IT staff to support and maintain our network full time, right? So now we call our site campus area network, right? So we can see start to grow from this very simple network to now a slightly more complicated, right? And slightly more capable as well. And then so good, we say we open branches, right? So we open branches. Now we connect our branches using wide area network via the internet. And of course, we provide some security by using VPN, something like that, right? So that means these are all remote. So that means now we have Penang, Perak, Pahang, Johor, and Sabah, and main campus, all different sites individually will have their own campus network, but now connected via the public wide area network, right? It becomes at first a branch in site in the city, and now it become regional sites, and once it covered the whole Malaysia, I think it's a national wide network already, right? So we can use public wide area network like the internet, right? But if you once you reach here, for example, in the branch office here, right, you can then uh, basically, oh sorry, from the branch here connecting to the ISP to connect to the wider internet wide area network, we then use dedicated lines already, dedicated lease line. So for example, the network in our Alam Mesra, from our campus to the telecom, we actually have a lease line. Okay, so that means the bandwidth from our campus direct to telecom is a lease line. The bandwidth is belong to us, fully belong to us. Okay, but of course only when until telecom. But once from telecom reach the internet, then the bandwidth is shared already lah, right? Yeah, so something similar to this lah. Imagine that the branch office here is the Sabah branch, Alam Mesra. Central office is main campus. So we connect, I think Metro, I'm not sure it's the service Metro from telecom. So we connect this line here, fiber optic, right, to the service provider. And then when it reach here, then to connect to other branches, it will be via the internet wide area network lah, right? But then when it reach locally near to the main campus, is again from the TMnet, telecom, again this line, right? So here to ISP this line, here to ISP this line. Now, why this line? Because a traditional consumer one, we are sharing bandwidth now. Okay, if you connected to MNet or Unify, you're sharing the bandwidth, the local loop here from your house to the server in telecom. You're basically sharing that line with other subscriber, right? So when there are too many subscriber on that particular line, then your bandwidth will be shared, will be down, will be low lah, right? Now for ours, because we get for our campus in Alam Nusra, we get the lease line, means from our campus until telecom, there's no sharing. That's a lease line. We have full bandwidth. Okay, so this is what we're talking about here lah. Just give an example about our own campus, which is the same lah. Right. So where do you go from here? This is national, I think, nationwide. So after that, you'll be beyond individual countries. When it goes beyond individual countries, then you start to see this kind of situation. That means it's now go all over the world. So basically, every time you start to use the cloud, okay, you're basically doing this. Okay, when you're using the cloud, of course, that one is a service on storage service online, right? But what I'm trying to say is that Google has a data center all over the world, right? And you're probably accessing the ones nearest to us, lah, right? When you're using Google's cloud storage, right? Now, imagine your company now become so famous in Malaysia that everybody knows. So now is there enough to open branches in other countries. So how do you connect to them? Of course, via the internet. The internet is the only infrastructure that can go global, right? But then again, like I say, your traffic go beyond uh, your own country. Okay, a lot of things. Even in your own country, also you can't trust already. Definitely, when you go the traffic go out of your country, because different types of cyber law, different types of enforcement of cyber law. Okay, people, there are syndicate out there that can hack into your communication. So you can protect yourself by using virtual private network. Virtual private network basically end to end. Okay, end to end from sender to source to destination, end to end encryption, right? So people cannot intercept. Well, they can intercept, but they can't read what they intercept because it's encrypted. All right. So we just saw very briefly or very quickly the path a company can take in their growth from a small Soho, small office, home office, until become a international corporation, right? And their needs grow. Okay, I can't imagine already if like this. I have no experience when it goes to international like this already, right? I'm pretty sure you go for those international. You can I think connect through our own telecommunication company like Telecom, and then they deal with us with other large, even larger than Telecom, large telecommunication company that works internationally, right? I'm pretty sure you can do that. Well, of course, the cheapest one is you don't even do that. The cheapest one is you simply use the internet. No one can control. If you just use the internet, okay, I can connect with our company. Let's say I have a company here in Malaysia and another one in UK. I can simply, okay, make sure I have a good bandwidth here and also there at the UK. Can simply create a VPN, right? And I will be secure enough to actually remotely open up a computer in the LAN, okay, in the in the branch that is situated in UK, for example. That is how good it is using VPN. We can open, we can have like a a direct PPP, a point-to-point protocol here. We can even say like I'm part of the LAN here because I'm actually remotely, accessing one of the computer inside the LAN, right? Inside the LAN, inside the internationally, right? So that's cheap using VPN. So as long as I have a good bandwidth with my ISP here, and also same thing at the UK side, then I can just create a VPN, right? Any question?
No.
Yeah?
No.
No? Huh? Okay. So let's move to the next section we call wide area network operation, right? So let's have a look. So first of all, let's look at wide area network standards. Okay, so modern wide area network standards are defined, managed by a number of recognized authorities. We have TIA, EIA. These are, TIA stands for Telecommunication Industry Association. These are very big organization, and um, they also are responsible to create the standards and create and update standards. Telecommunications Industry Association, Electronic Industries Alliance, ISO, the ISO that we know, the implement standard, International Organization of Standardization, and IEEE. Okay, although we mostly know IEEE for local area network, right? But they also have some standards that is used in wide area network. So Institute of Electrical Electronic Engineers. Let's look at the OSI model and how where is WAN services at, right? So one standard focus on physical layer and the data link layer. So that is why a lot of these large companies that builds infrastructure, internet infrastructure, usually they are telecommunication company, because when we talk about infrastructure, we talk about the hardware and the layer just above the hardware. So you can see layer one protocols. Wide area network standard focus on physical layer, which is layer one, which is the hardware. So the protocols we see there are synchronous digital hierarchy, right? Synchronous optical networking, SONET. That means this one is fiber optic, basically, yeah. And dense wavelength division multiplexing. Then layer two, okay, we know that is part software, part hardware as well. Here lies the broadband, DSL and cable, wireless, any kind of wireless, not only Wi-Fi, including Bluetooth, WiMAX, and all those. And then even the satellite communication or wireless. Ethernet, a wide area network, metro Ethernet. This one is citywide, okay, Ethernet. Right, MPLS, multi-protocol label switching, point-to-point protocol, PPP, is less used now. Last time it's used, this one's still used for ADSL2, I think. And also for the public switch telephone network, last time we went to use the modem. It used a lot of these PPP, although it probably is a logical PPP. Right, and then we have high-level data link control, frame relay, which is legacy protocol, and then asynchronous transfer mode, ATM, also considered legacy now. Right, so let's look at some of the terminology that is being used when we're talking about wide area network, right? So we are talking about wide area network connections between subscriber. Okay, subscriber are, you subscribe to their service, so it could be company or client, and the service provider itself, right? So we have DTE. I think DTE, DCE, you guys already seen when you're trying to connect serial cable in packet tracer, right? So actually that data terminal equipment, or DTE, okay, connects the subscriber LAN to the wide area network communication device, right? And then the data communication equipment, or DCE, is a device used to communicate with the provider. right? So the provider is at the provider side lah. So your device there to communicate with the provider. So from the client side, right, the provider give the client the wide area network communication device, right? And then so we connect your LAN to the communication device using data terminal equipment lah, DTE, right? And then if you have both DTE and DCE, right, at the edge of your enterprise, means the boundary between your enterprise network and the provider network, you got both DTE and DCE, then we call that customer premises equipment, or CPE, right? And then we have point of presence, or POP, not the mail, not the mail one. This one is different. Point of presence, the point where the subscriber connects to the service provider network. And then demarcation point, the physical location in your building or complex that officially separates the CPE from service provider equipment. So this terminology is a way for you to understand the lingo used when your organization wants to connect to the wide area network service provider. They will provide you equipment, and they have a special terminology, right? So the description here, when they say, point of presence or demarcation point, so these are the meaning for it. So here, as illustrated, okay, it illustrate where this all this equipment here, or the boundary exists. Okay, all right. Right. We continue. Okay, local loop or last mile. Local loop or last mile is basically from they normally have a device whereby from the device they separate a small bandwidth and then carry it down to the customer's location lah, right? So there could be a box outside, and you connect the line into your home, right? So that's the last mile already. It could be a copper for cable or fiber optic cable for Unify, perhaps. We don't have cable here. I'm not sure in Sabah they don't have. Maybe in Kelang they have cable. Not sure. But what we are mostly using here in Malaysia is fiber optic, okay, provided by Unify lah. So when they pull, they say they have a box out there. It could be a switch, or it could be something that can divide bandwidth, but actually they have a large cable, there's a multiplexer, then one of the two cables within the big cable will be connected to your home, right? So that means in one big cable, I'm not sure how many lines do they have there. So each line will have up and down, upload, download lah, for fiber optic, right? So last mile means from that large big cable where all the cables are there, right, for user, then they pull one cable with the two fiber optic, right? I think they just put into one cable. There are two lines, there are two fiber optic lines, then bring out to your home. Okay, that's the last loop already, last mile. Sorry, local loop last mile. Right, and then we have central office. Central office basically is used to describe local service provider facility or building that connects the CPE to the provider network. And then tall networks include backhaul, long haul, or digital fiber optic communication lines, switches, routers, and other equipment inside the wide area network provider network. So normally this tall network are those usually hidden by that cloud symbol. Right, whenever we say we go to ISP, there's the cloud. So all those hiding this kind of equipment, right? So backhaul network connects multiple access nodes of the service provider network. They themselves have their multiple networks, so multiple LAN. So they also have to link them together, right? So that means if they wanted to provide service to, let's say, in Penampang, right? So in Penampang area, they can consider which area in Penampang, which area in Penampang. It's the same thing as when you're creating network in your LAN. They have to provide the addressing and all these things, right? So their backhaul network also will connect all this connectivity to the consumer, right? Backbone network is the basically going to the internet already, the high speed. This one is the one that I said that not all companies are allowed. Usually the government will appoint, okay. In some countries, they have multiple telecommunication company that can have access to backbone network, right? Depending how large the companies are. But in Malaysia, I think only one company that is provisioned by the government to manage this backbone network. So you can see backbone network is actually very high speed access to the internet already. So it's large, high capacity networks used to interconnect service provider networks and to create a redundant network. All right. So following with more terminology, voice band modem. These are the old legacy ones. I think it's obsolete already. Okay, in Malaysia, this should be obsolete. This is the old dial-up modem. When you try to connect, when you're using modem last time, this one, you cannot use the line for phone call. It's either you use it for phone call or you use modem. So there's a splitter and it's on a maximum speed, I think 56 kilobits per second, right? That's the fastest, I think. Whenever you try to dial up to connect to the ISP, you'll hear that modem ringtone. I think you guys know that one. If not, you can check on the internet. They still that I think they still have some. I remember some people upload that legacy dial up modem sound on the YouTube. You can try. I mean, this one is a legacy. It's not available. I don't think even if you still have the modem, you cannot use it anymore because there's no service already. There's no service from the ISP. Okay. So this one use telephone lines. They use the public switch telephone network to carry the signal, right? Okay. After the end of this voice band modem came the era of DSL modem, or for us it's ADSL. Seldom we have cable modem, right? But in Western country they do have cable modem, right? So most of us got ADSL and ADSL2, the latest version after that. Right, so these are called broadband modems, high-speed digital modem connect to the DA router using Ethernet. So digital subscriber line, DSL. We call it ADSL because asynchronous. For us, it's asynchronous, meaning our download speed in Malaysia is higher than our upload speed. Our upload speed actually slower than download speed. That's why it's asymmetric. And then we have CSU, DSU, digital disk line, requiring a CSU and DSU. It connects digital service, digital device to the digital line. Optical converter connect fiber optic media to copper media and convert optical signals to electronic pulses. I've never seen this one. I think if the line, okay, from the subscriber is a copper carrying electronic pulses, when it reach the internet service provider, they might have converter to convert the electrical pulses into optical signal. It's basically just convert between electrical to optical and vice versa, right? Wireless router and access point is typical of a way for us to connect to Wi-Fi, right? So we all know what is a wireless router and access point, right? If we have consumer base at home also, we'll have this device all in one, including wireless router and access point all together in one box, right? And then wide area network core devices means the backbone, which consists of high-speed routers and layer 3 switches, right? So you can see that the symbol used in diagrams here, in Cisco diagrams, right? DSL modem, cable modem, voice band modem, CSU, DSU, optical converter, and such, right? Okay, so any question? Wide area network devices? Basically, here just a way for you to get to know some of the terminology used when consider wide area network.
No question.
Okay.
It's okay, this like a glossary this part. So let's look at the serial communication. So serial communication, okay, you can see by the name here, and also in packet tracer, you've been using serial cable to connect router to router, right? Okay, so the name serial means the bit are transferred one after another, right? You you basically compare this against parallel communication. Parallel communication means the bits are transferred all at the same time, okay, using separate cable, right? So that means serial communication, you only need one line, one wire. Parallel means how many bits you want to transfer at one time, then you need how many of that wire. So if you need to transfer 8 bit at one time, so you need 8 wires. Okay. So for serial, you only need one because the bits are transferred one after another. Okay, can tell the difference, huh? So the bits here needs to transfer, so 1 bit at a time. Here the bits you want to transfer 1 bit, one wire. So potentially all bits can travel together at the same time. So of course, you think that parallel communication is faster than serial, right? Okay. So yes, it can be parallel communication can be because multiple bits at any one time, right? The limitation is if you want to expand, then you need to put more wire, and if there's no ability to add more wire, then you're limited to that, right? Whereas serial communication depend on encoding, right? And also encoding in order to speed up lah, right? Because bits physically have to travel through the line one after another. Okay, so you get a pattern of 1 0 1 0 after one after another. Now the thing is, remember, bits have to travel through the lines, we say, at the same time, right? So what mean by at the same time? Means we need to synchronize. We need to synchronize the encoding, the signal here, right? What's bad is if we lose the synchronization. If we lose the synchronization between one wire to another wire, another wire, another wire, right? Then there will be corruption. Okay, for short distance, no problem lah, no problem in keeping the synchronization. But as the cable length increases, the synchronization timing becomes harder because small difference at the beginning over a long distance, it will be amplified. There will be a difference in timing, several magnitude that there will be corruption already. So that's why parallel communication is only limited to short distance. And serial, no problem. There's no need to synchronize, right? You just send the bits one after another, right? That's why for long distance, serial communication is preferred. Is that okay?
Okay.
Okay.
Noel, Farah, Kelvin? Okay, all right. So that's serial communication. Next, we want to look at circuit switch communication. So there are two types of communication, either circuit switch or packet switch. The circuit switch is the old type, right? Circuit switch means it's a physical switch, whether it's an analog or digital switch. It's physically creating connection to form a line of communication, right? So that means if I make a phone call from A to B, and the switch here switch from here to here, and this switch not switching here, but switching here, this switch switching here, this switch switching here. That means when the switch already established a path between A and B, for example, like this, right? Then it will remain. It will remain for the duration of the communication, right? And this path has to be established before communication can happen, right? Okay. Then after you A, for example, finish talking with B, then only the switch can be released, and then that's it. Communication is stopped. Right. So there are two types. One is the analog public switch telephone network. I mean, analog here means the signal is encoded in an analog way. Analog means the if you look at the signal, electrical signal, it will be continuous like this, like this, like that, right? And the second one is fully digital. So the signal that travels is encoded like a digital signal. Okay, so that's the difference between public switch telephone network, which is analog, and ISDN, which is digital. Simply means for public switch telephone network, the one that we use, the old modem type, okay, is analog signal, right? Analog signal. Whereas the ISDN is using digital signal. Okay. So ISDN is using packet switch network. Circuit switch communication. And then and PSDN also using circuit switch communication. So remember when you go in Malaysia, okay, they can have automated switch. But last time, if you want to call overseas, I think before your time, you can ask your parents. I think your parents still remember. If they want to call overseas, they have to call the operator first, and then the operator will connect you. So this is physical connection. This is a switch, physical circuit being connected, right? So these are circuit switch communication. Now technology improve, whereby everything become digital. So we talk about the trends, right? One of it is converged network. Converged network means the infrastructure is no longer using circuit switch. Now we are doing packet switching. And correct, packet comes from the packet in the network communication. So packet is being switched, right? Packet is being switched across the communication infrastructure. So you can see segment traffic data into packets that are routed over a shared network. Much less expensive, more flexible than circuit switching. Because, for example, why not flexible? Once you create the circuit here, then you cannot change it in the middle of the conversation, right? If you cut here, that's it. You have to re-establish another circuit. Okay. Whereas here, the packet is being, it can flow. If you have multiple paths, then it can, your conversation is segmented. It's divided into small pieces. So one part will come here, another part will come here. Just like what we discussed already about the network layer, the packet being chopped up in the transport layer, and then the packet small, and then just being forwarded via router. The router can choose to forward any path lah, depending on its routing table, right? Okay, so common types of packet switch: one wide area network, Ethernet wide area network, Metro Ethernet, MPLS, and asynchronous transfer mode. Right. So I have to say, you have to see this This is not routed. All right. So you only see this when we're discussing wide area network, right? They are using a different technology in terms of when we are doing in telecommunication. All right. We'll see further here, right? Oh, sorry, there 7.3 later, traditional wide area network connectivity. Right. So let's talk about these three infrastructure: SDH, SONE, and DWDM. Service provider networks uses fiber optic infrastructures to transport user data between destination. Fiber optic cable is far superior to copper cable for long distance transmission due to its much lower attenuation and interference. We learned about this before. Copper cable cannot go for long distance. Fiber optic can because it's using light. Light is immune to EMI, electromagnetic interference, and radio interference as well. So it's um, is immune to that. But copper cable is prone to outside interference, also crosstalk. Okay, and attenuation simply means the signal in a copper cable loses energy over distance. Right. So when it loses too much energy, the encoded signal is lost. Therefore, data is lost. Right. Okay. Attenuation simply means loss of energy in the signal. Okay, if you want to prevent every distance where the attenuation can before the signal get too eroded, you have to put a repeater to boost the signal up again, right? Okay, so that means for long distance, fiber optic is the best medium, right? So two optical fiber OSI layer 1 standards, okay, layer 1 physical, available to service provider. One is SDH, second is SONE, right? Synchronous digital hierarchy is a global standard for transporting data over fiber optic cable. So it's just a standard to be used. So everyone can, device can talk to each other, right? And the cable will carry the same same signal, right? Encoding. SONE, synchronous optical network, is the North American standard, provide the same services as SDH, right? So both SDH SONE define how transfer multiple data, voice, and video communication over optical fiber using lasers or light emitting diodes over great distance. Over great distance, that means across continents, right? When you think about the fiber optic cable underneath the ocean, right? Then think about the encoding will be this two, either of this, right? I believe because it's not American, it's SONE, so SDH reach there, it will be translated. Yeah. So it's a converged network. Okay, all kind of communication can be encoded lah. Data, voice, or video also can. Right, and then we have the dense wavelength division multiplexing, or DWDM. It's a new or relatively newer technology that can increase the data carrying capacity, right? So it's multiplexing. So that means it's for me, it's layering streams of data within the current bandwidth, right? So that means if you have one wavelength of light and you encode data over it, so that one data after another, like bits, right, streaming in that wavelength. So if you have another different types of bits, imagine parallel but not wires. Instead of wires, it's frequency of light. Wavelength basically is frequency of light, right? Just like a white light, you have if you the primary colors, there are 7, but actually there's a slight gradient of colors between, right? So if you have red, blue, green, yellow, things like that, right? Different wavelength of light, right? So laser light also, you can generate individual, right? Why laser is good? Because laser laser light by definition is that you can basically isolate a single spectrum, okay, a single wavelength of light. So it could be blue, could be green, right? And then there's no other light, no other color or spectrum inside it, or wavelength. So if you are utilizing a different wavelength of light, so you encode different data in different wavelength of light and mix them together. This is a multiplexing part, right? And then the dense wavelength means you pack them together, right? If you're thinking how do I combine? Well, white light is actually a combination of all the spectrum, different types of different wavelength, right? Something like that, but separated in terms of you can keep track of the encoding per wavelength if you choose which wavelength, right? And it's generated by the laser, each wavelength flight, right? So it's a newer technology. That's the best I can explain, because I think if I want to explain further, I have to go and read the physics part of it, right? The algorithm of the physics part of it. All right, so basically that's all you need to know is these two are standards for long distance optical fiber encoding. And then this one is a way to make it even more bandwidth, even higher, okay? Increasing the capacity, data carrying is the bandwidth lah, kan? The data carrying capacity of these two by using this technique. All right? Is that okay, everyone?
Okay.
Okay.
All right. Okay. At the moment, it's 2:56. Although, I know that. Okay, let me just. I know next week is VPN IPsec, but I think when wide area concept is too big, to cover in this lecture. We already reaching 3 o'clock. So I believe, all right, let's rest here and go for a break.
Okay.
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 Right. So we start at 3:10. Is that right? 3:10.
Do we need to go to the other meet?
Yes, yes. Come.
Oh, okay.
Join me in the other meet. Yeah. Thank you. Hello, welcome back. So I'm going through all the tutorials again, right? And can you also go through all the tutorial again? And I think we just do revision and later. I will upload the tu- tutorial for this week, which is tutorial 6 DHCP version 4. But for now, I believe that the best way is to just we do a revision for tomorrow. So some of the questions, example, Farah, you're looking at, let me just go back here. I made a comment here, right? So show IP route, and then with reference to R1, partial output of show IP route, command differentiate the two static routes. So there are two. One is the next hop static route, and the other one is directly connected static route. So whenever we say static route means it's manually entered, not exchanged using any OSPF or EIGRP, right? And here, this one already answered. Yeah, differentiate. Okay, so here, a default static route versus floating static route. You need to know what's the difference, yeah? So floating static route, let me just check what is that. Okay, so okay, it is commonly used when connecting edge router. Subnet mask is 000. Yes, address and the subnet mask will match any network address. It's for match all route. Okay, so let me just give just an alternate answer. That's correct, but I just give anyway with the mention of gateway of last resort. Okay. Okay. Floating static route. This is to configure floating backup connection or backup path. Correct. Okay, there you go. Backup path. Right. Okay. The administrative distance. No, another. Okay. Cool. All right. So make sure you guys know what is the difference between default static route and floating static route. Okay, number 5. Based on the network logic, we answer the following question. IP route. Okay, yeah. Default static route. Okay. So exit interface of R1 is that S0000, which is correct. In router 1, write a command to configure summary static route for network between 0 to 20 to 50 in next hop address. Summary. When you summarize it, okay, summary. Hmm. Well,
Or is my answer wrong?
Yeah. Hang on, I'm looking for some. Ah. All right. Okay, enter routes. T to T1. Mm. Mm. For the link, put in this value, you can see the calculation. So the binary part, the first part is 172.16.2, and then the second part is 772.16.5. So you want to create a root summarization, right? So the subnet will be 255.255.248.0, right? And then the next IP address is 192.168.22. We summarize all the the network that you can reach by 192.168.22, right? So you can see the whatever network, it will match 172.16.0.0, whether it's 2.0 24 or 5.0 24. But of course, when you are doing 172.16.0.0, you put in /21, means all the way the matching until, remember the length, the maximum length is the one that is going to be detected. Right? So that calculator there is a root summarization calculator. Right? Just put in the list, okay, for the range, and it will provide to you. Okay. So then you give in the route summarization and then the subnet mask, right? And then write the interface that is going to go through. Okay. In router 2, write a command to configure standard static route for network 192.168 using the exit interface. The standard static route for using the exit interface should be the S00000. So G00 is the not exit. The exit is this one. When this route, when we are talking about, oh, hang on, it's router 2. Router 2, the exit, okay, exit from this LAN, this here will be this one, S002. So G00 is entry lah, non-exit. Okay, to go to this remote network, right? 192. So that means Farah for C, right? You want to be able to direct traffic coming in from this network, okay, this network on the right hand side of R2 to be able to be forwarded to this network here, remote network. So this network is 192.168.1.0. Exit interface is here, S000. So I believe this one, correct. Okay, but with this one, exit interface. Is that okay, Farah? Right? This is the exit interface of R2. And to go to this remote network 192.168.1.0. So you're probing because you manually entered it, so it's a standard static route. Okay, it's actually saying that one. So okay, Farah?
Okay.
Yeah.
How do you answer the summary? It's just that one line only.
Yeah, just one line only. Summary is one line only. Right? Okay, so and like this one for C is only one line because basically the incoming is from here, from this network directly connected, wants to go to this network 192 because it's one hop away, right? There's no entry in R2. Okay, here we have not learned about sharing of routing table yet. R1 haven't shared, so R2 have no idea about here. Okay, Farah? So that means you as the network administrator, you need to put that static route here so that this routing table has the entry for this, which means to go to this, to when the traffic go here, it match this one. This is exit interface. So that's why here, to match this one, to go this one, right? To match this with this subnet mask, go through this interface. S000. This one, S000. Okay? If you don't put the default route, this router only have this, and this M3. Right? And going to this side, then you have to put the default route for this one and this one in here. Right? And here to go and then also same thing lah, right? You have to, if this is for router 1, this and this are remote networks. Okay, for R3, this and this directly connected. This one directly connected. This one directly connected. But this and this remote to R2. This also remote to R2. For R1, this and this directly connected. This remote. Okay. So here, what we want to do just now, again, is to where was it? Oh, deleted already. So Kevin, it says 172.16. We want to, because this all these are 172.16. We can summarize it. So that means, but when in R1, whenever it's matched, the most, okay, is between range. If you look at the binary I shared in the chat, the binary of 17162 and 17165, you can see that is slash 21 means the first one is 8, 8, 8, 16, then 5 more, 1, 17, 18, 19, 20, 21, slash 21, right? Slash 21 means you can get this subnet mask, right? So we summarize this one slash 21, we subnet mask via the this address interface. That means here this one lah. Next hop address using next hop address. So R1 next hop address is this 192.168.2.2, which is this one. Okay, and it will match all these addresses. It's summarized these addresses 172.16.3, 172.16.4, 172.16.2, 172.16.5 is summarized into this.
Oh, okay.
Yeah. Okay. So there is a way to calculate the summarization, but I gave you the calculator there already. The one I shared, the one I shared in the chat. The first link is the explanation. The second link is the calculator. All you need to do is provide the range 172.16.2.0 dash 172.16.5.0. Then you can get the summarization. Right? The first link tells you how to do that. I mean, what's happening with the summarization. The second link gives you the calculator, easy for you to calculate. Right? Okay. Let's move to D. Okay, D. In router 2, write 2 commands to configure fully specified static routes for network 171.16.4 and 5. Right? So 4 and 5. Okay. Slash 24. G0, 01, 32, and 22. 32 and 22. Okay. So it's specified. Next hop address. So this is correct. Okay. No, correct. It's a fully specified one. So let me just put in. Okay. Okay, like it, Farah?
Okay.
Make sure you understand, huh? Tomorrow definitely come out static and default routes. All right, so this one is question. Ooh, what question number is this? 6, ka? 6. I. It's missing. Suggest. Where is it already? Standard static routes using. That's a question already. Yeah. What's the question? Huh? Let me check what's the question really. Is it number 6?
Yeah.
But number 6 different question, no? Oh, I think it's number 7 already. Yeah, that's number 7 question. Standard static routes based on figure 1.1. This is number 7. Number 6. Oh, yeah. Number 6 is Kelvin punya kan? Okay. Suggest the most appropriate routing methods to be implemented for small network topology shown below to forward packets from R1 to ISP and vice versa. Justify your answer. Default routing method. Default routing? Bukan static routes? Default route is the gateway of last resort kan?
Oh yeah, not so confident about my answer.
Yeah. So cannot use default route because default route is actually if you have the switch statement is the default. Yeah. So is should be static route. Right? Should be static route. Okay, Calvin, and you can then you can provide the reason. Okay. Basically, the result is because less processing is power is needed by the router because it's fixed, right? So no CPU cycles used to calculate communicate that route is a static route.
That's power needed to what?
Need to calculate, or you can say less CPU power cycles, less CPU cycles needed to calculate and communicate the routes, the static routes. Okay.
Yeah, is that okay?
To calculate and communicate. To calculate and communicate. Because if it's dynamic, it has to recalculate every the what can it has to recalculate what's the best path. But default routes is entered by the network administrator, so there's no need to calculate anything. Just it will just be an entry there. The router just follow it. So less CPU cycles needed to calculate and communicate between routes. Yeah. Communicate routes. Communicate routes. No between. So communicate routes between routers lah, kan? Communicate the routes between routers.
Okay. Lagging.
Okay. Okay, I'll do that. Yeah. To communicate routes between routers. Figures 1.1 shows a network topology with Internet Protocol version 4 configuration done on all routers interface and personal PC. Based on figure 1.1, determine the appropriate static routes configuration with justification in the respective routers. Age and FOCS ISP is already pre-configured with static routing. Use table 1.1 to document your answer. Standard static routes using next hop IP address. PC1 and PC2 are able to communicate with PC3. PC1 and PC2 is PC1 here, PC2 here, able to communicate here. So we need to configure this on this FOCS router, okay, to enable. So I mean IP routing 171.16.12.0 and then 255.255.255.0 S001, I think, yeah. Right. Oh, sorry, I just know, Kelvin, you are talking about static route as in default static route, ka?
Yeah, I think. Oh, that should be default static routes. Is that right?
Yeah, correct, correct. Sorry.
Oh,
Okay, correct. Static route, but it's a default static route. R1 you can configure default static route because it's only one direction anyway, right? And then you just pass the processing down to the ISP router. So good idea lah, default static route. And then ISP will be configured using summary static route. Yeah, so that means anything from the ISP will go to the matching your internal network, then it will be summary route. Yeah, correct. So so for fairer, how to answer this? We'll do for FOCS first. For FOCS, FOCS here. Next hop IP address. So FOCS going into 172.16.12.0, 255.255.255.0. So IP route that network, and then this S001, right? S001 is 172.16.1. Oh no, next hop is 2.2. Next hop is .2. Yeah. So for FOCS, you're watching, Para? For FOCS router,
Yes.
then it's IP route. Since if from inside FOCS here, it wants to go to from PC1 and PC2 go to PC3. That means you have to set in FOCS router where to go to PC3. So that means to go to match 172.16.12.0, 172.16.12.0, and it's slash 24 is 255.255.255.0 slash 24. You need the next hop router, next hop IP address is this one, .2. So you can see there, the edge .2, but this .2 is part of this network, 172.16.1.2. Okay, so let's put down there 172.16.12.1.2. Where do I get this? Because this interface there is .2, very small, cannot see, but .2. Okay, that means the interface .2, but part of this network. So the network is 172.16.1.0, right? But this is .2, so 172.16.1.2. So next hop address is this. So in order to go here, you need to forward to this next hop address. So correct lah, right? For FOCS router. Now we also have the edge router, right? So the edge router go to these two places in FOCS. So reverse edge. Let's say we want to go to this one first, let's go. We want to go to PC1. So same thing, right? Same thing. We have to for edge, then IP route. Yeah. Okay. To go to this one 192.168.44.0, 192.168.44.0. Again, it's slash 24, so 255.255.255.0. And then what interface? Next hop interface is this one, which is .1. So 172.16.1.1. Okay. So 172.16.1.1. So another one, which is also on the edge router, is to go to the other one, which is this one, this route, this network 56, right? 56. So IP route 192.168.56.0 again /24. Same 172.116 because it's go to that interface. Right? Is that okay, Farah? So now you have set the standard static routes for both FOCS and edge router. So FOCS is for traffic going into here. So the edge network you set is for traffic going into this and this. Okay? This and this. Is that okay, Farah?
Okay.
All right. The rest okay, ka? For that part.
Yeah.
Okay, I hope you are, Kelvin.
So
Yeah.
the on route the FOCS, right? Do we can we put the summarization?
Oh, yeah. Actually, did the question ask?
Um,
You can actually.
no.
That's the whole point about if it's very close to the, very close to the, what do you call that, the addresses bar very close to each other, you can summarize.
Oh.
Yeah, but usually wait until the what is actually asking lah. The question is asking, then uses as, wait. Right. So let me see here. Number 2. Okay, so number 2, default static route as primary route using next hop. PC3 is able to ping external PC, make assumption, external PC ping, okay. Yeah, you're doing a default route, default static route, right? 6, 6? Yeah, can. Let me just grab this. It's correct. Goes with the primary default route. Right, number 3, default static route as a secondary route or backup route using next hop address. PC3 is able to ping external picture assumptions. This is default static route. Secondary or backup route. That means it's floating. 2090010 9. Where's the 9 coming from? 9 and 5. 5 is okay. That's administrative distance. So you assume. So basically, if you put 5, you can say assume AD equal 5 lah. And then edge will go to ping primary route is the 9.5. Okay, so you just basically give your own address, is it?
Yeah.
Is
The
it
9, the 9 based on the edge there.
Next hop address is 905. Default static route single route applicable using PC3 is able to ping external. We are going to ping to external PC.
Oh.
So next hop router and next hop address, Next hop address is not 95.
It's used. This one use secondary. They want use default static route as secondary.
Yeah.
So
So it's either use the other one or the other one. It's a
use
floating.
this.
Yeah,
use
you
the
make
second
floating.
one.
Yeah, or this one, right? The first one or the second one. But if you put, so that means it's either like this. It's or this one, right? So this one is a floating route, default route. But the next hop is not 9, no? It's 10, right? The other one is 10 and the one is 6 because we're trying to ping external PC.
PC3.
Yeah, so we are going next hop address, right?
Not 9. There's two. Since there's 2 routes.
Yeah. Next hop address is after edge is 10 and
10 and 6.
10 and 6.
On.
And yeah, 10 and 6. So either 10 or 6 lah, right? So the other one is 10. Yeah, that one is 10, and the other one is 6. And if you use administrative distance, put both the same.
But didn't they only want the secondary route?
Oh yeah lah. Whichever lah, right? Whichever.
If I put the distance in one of them, then this one becomes the secondary. I think.
Yeah. So either this one or this one lah. You set as default route because we say all ma.
We only set one, or you set if I set both.
Yeah, you can, if you put like this means either you use this one as the default route or this one as default route. So that's why you put all.
So the question wants us only one secondary route. The question only wants us to only want us to make one route.
Or you can put just one answer. If you put one answer, either this, either that, because we are talking about backup route. The default route is up here. So here, Noel only answer 1. So this is correct. But if we answer the other one with 10, then it's still correct, right? Or he can put both answer, he put all. So that means yours also the same. You can either just answer this, or you can answer this, or you can put all here. So either one can be used.
Then our question the same.
Huh?
Our question the same.
No, yours is backup. So that means yours backup has this.
Okay.
Your assumption is your AD is 5. Right? Because you put 5 there, Magan. That one is administrative distance.
Yeah.
So that means you assume your administrative distance is 5. Right? So either your answer is this or your answer is this. Both equally can be used as answer. The only reason I put all is because you put 2, ma. So I put all here. So that means either, not both at the same time. Either. Okay? Is that clear, Kelvin?
Okay.
You can put both, but you have to put all. Means either this or this. You put in. Is that okay?
Okay.
Yeah. Right. So just remember, for secondary route or backup route, you have to put the administrative distance. Anything less than the default. What's the default? Anybody can tell me?
1.
1, right? So anything above 1 will do. Right. So okay. So here, number 8, is it this one? Number 8. Hey, what's this one? Documentation table. Oh,
17.
yeah, you already answered here, kan? Documentation table.
Oh, is it the same?
I think it's the same. Router name item, yeah. So the answer up here, right? Actually, it's the same. Sorry, yeah. So Farrell answer here is the answer up here. Okay, just put C above. So yeah,
Okay.
C above. This one also above. Yeah, the answer here already 2 and 3. Okay, or you can copy paste your answer here to here. Right. Right. So this one will come out. Yeah. This, well, not this exactly, but like this will come out tomorrow. So be prepared. You need to know the how to set default and default static route, default static route, and backups. Okay, backup route. Okay, let's look at number 8. Number 8, the question is sorry, configure IP version 6 static route in all routers shown in figure 8.1. All right, so make sure you learn about this, how to do in, well, basically, this is IP version 4, right? And make sure you know how to do for IP version 6 as well, okay? So the number 8 is basically IP version 6, right? Configure IP version 6 static routes in all routers shown in 8.1. So we have R1, this one is what? We'll see. This one is R3. Not sure what it should be R2, is it? Not clear, kan? Let's see. R1 configuration. Oh, only R1 and R3, is it? R1, R2, R3 also got. R2 also got. Okay, R1 first. R1 IP, okay, unicast IP version 6, unicast routing. Okay, so that's correct. Let me just get my tick mark. Correct. Then /64 series route 20 DB8 ACAD 3 3. Two zeros. Okay, this one is correct. This one no need. Mm. This one one. IPv6 route 640. This one no need. Then why do we have these two similar?
Look at the third object. One is ACN, another one is cafe.
Oh, cafe. All right, ACAD. Okay. So I wanted to do this one. Yeah, cafe. ACAD. Why ACAD go where? R1, you want to go to here, here, here,
C2.
here.
The green area.
Want to go to ACAD 1, here. Want to go to cafe 1, here. Want to go to cafe 2. So only this, and this from here. We don't need to this one. This one is directly connected, so don't need. So ACAD 3 no need. This one will be directly connected, right? So no need this one. This one is directly connected, sure. Everyone can see? Because ACAD 3 is connected to R1. ACAD 2, oh, this one also. This one also. ACAD 2 also directly connected. So this one also no need. Anything that's not, you don't have to, if it's directly connected, you need, the entry is automatic inside the routing table. You don't need to set. So we need to go to, be able to go to ACAD 1, TB8 ACAD 1 here. So this one. Right? And we need to be able to go to Cafe 1 and Cafe 2. Cafe 1 and Cafe 2. Yeah. So this one. And we don't need this. Okay.
Okay.
We enable the IP version 6 unicast routing to enable IP version 6. So by default, it's not enabled. It's IP version 4. IP version 6 unicast routing. Then we need to specify, we need to be able to go to this one, ACAD 1, Cafe 1, Cafe 2. So these two, no need, because R1 is directly connected to these two network. So the entries by default will be inside the table. So this router 1 needs to go one hop. Okay, here ACAD 1, Cafe 1, Cafe 2. So ACAD 1, Cafe 1, Cafe 2.
So,
Right, of course, it's not cafe. It's basically hex value. All right. So okay, that's for R1. R2. Let's look at R2. R2 is here. Directly connected is this. So the entry will be inside there already. Of course, you need to specify unicast routing. So R2 needs to go to this ACAD 3 and Cafe 2. So R2, this is correct. So I need to go to ACAD 3, and Cafe 2. Cafe 2. Okay. Oh, sorry, not there. So this one no need, directly connected. Anything directly connected, no need, huh? And we don't need that. We just need the either use the next address, next hop address, or the interface. Okay, so this one strike 2 plus, and this one we don't need strike 2 as well.
So in IPv6, there's no such thing as a fully specified route.
Fully specified. Or maybe can, no? I didn't imagine that we want to put fully specified. Here I just put the next hop address. Yeah, yeah, maybe can, right? Maybe they have fully specified, right? So, but the more important thing is this and this only, because get it, R2 directly connected, no need to do any manual entry. Only those that is remote, which is this and this. Okay, so R3, which one are directly connected? These two lah. This and this directly connected. So remote to R3 will be ACAD 1, ACAD 2, ACAD 3. So I will correct packet 1, packet 2, packet 3, and this on it, because they are directly connected. So the router knows this to network, so it will enter directly into the routing table. All right, so you guys need to know how to do this for tomorrow. Okay, Farah, Kelvin, and Noel.
Okay.
Okay.
Remember, if the router is directly connected, no need to do the default the static route. Okay, only the remote to that particular router. So this router directly connected, no need. Only this remote, right? This one directly connected, no need. Only this and this remote. What remote means? One hop away, one hop or more hops away. So this one, for this is one hop away, one hop. Okay, that one is remote. So we need to do the static route. This one also one hop. This one need. This one, two hops. 1, 2. So need. Okay. One or more hops away. All right. So that was, I think, finished that one. Tutorial 2. Okay, there's some here. Some here. So, okay, let's see here. Kelvin and Farah haven't finished this part. Please, and Noel also, tutorial 2. So tomorrow we have practical. All of you will be online, right?
Yeah.
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 So tomorrow for practical, okay, we'll try to finish this part, the tutorial, this part. You guys haven't. Can you guys try to do first? Then tomorrow we discuss. Okay. Immediately we'll go through. So part of you guys punya revision also, right? Then I think tutorial 3 is all done. Yeah. Tutorial 4, ACL concept.
Until tutorial 4.
Yeah, tutorial 4 in this part. Oh yeah, finish already this one. This one. So tomorrow, as much as possible, we'll do some revision first before. Yeah, here, Farah, please do. Tomorrow, prepare for the midterm test. For SCL, you need to know how to do the numbered SCL numbered and entry, and also the extended name ACL. Okay, so tomorrow we'll continue with our revision for the midterm tests. Okay, is that okay with you guys?
Okay.
Okay.
Yeah, so that means we can catch up with the practical later and also the lecture, but tomorrow is midterm test in the evening, so as much as possible we want to try to get good marks for it, right? So we'll continue. You guys can continue to do the revision tonight, and then tomorrow I will continue with further revision by looking at the tutorials. And if you have any other questions, then during the practical tomorrow will be the time for us to discuss. Is that okay?
Okay.
Okay, Kelvin, Noel, and Farah?
Yeah.
We'll do our best tomorrow, yeah? Okay.
Okay.
All right. So thank you for today.
Okay. Thank you, sir.
All right. I'll see you tomorrow, yeah, guys? Okay.
Okay, sir. Thank you.